Alright, we're going to try to apply what we just learned from the OLS tutorial. And so we're going to calculate the slope and the intercept of our regression by hand. In order to do that, we're going to have to use the means, the simple means or averages of square footage and PI. So I'm going to come down to the bottom of my spreadsheet and I'm going to enter the formula average, which is the sum of the variable in question divided by the number of elements in the sum, simple mean. Average does that for us, and I'm going to swoop up here over the values in that column, close my parentheses. So 2060 is the average square footage in my sample of 40 houses. Now I can go ahead and enter the same formula here, but I'm going to take advantage of one of Excel's great features, which is called relative cell addresses. So my average formula is actually averaging over B2 through B40, but if the position of the formula changes, it's going to update the argument of the formula or the data that go into its calculation. Meaning, if I copy this over by simply dragging my pointer over till it turns into the black plus, clicking and sliding it over, I have just copied the formula, and you'll notice that it automatically changed these cell addresses to C2 through C40. Okay, so what I have here now is my average values for price, $180,676, and square footage, 2060. I'm going to use those in this formula that I'm about to compute. So I'm going to first compute my house price minus the mean house price. So I'm going to enter the formula equals, I'm going to take my house price, that's C2, subtract the mean house price, but I want to amend this so that when I copy the formula, because when the position of the formula changes, the cell addresses are going to get updated. I don't want this this mean to be updated, so I can hold constant the cell row in this reference by preceding the cell row with dollar signs. So I'll try to explain what this is going to do in a second. So I'm going to go ahead and instead of allowing it to be C42, it's going to be $42, and you can think of the dollar sign as holding constant the row reference 42 when the position of the formula changes. So I'm going to go ahead and hit enter. So I can now copy, so I have C2, that's right here, minus C42. It's right here, okay? And I'm going to click and drag that formula down my worksheet, and it recalculates it, okay? Now, why was that important to put in the dollar sign? Well, let's scroll down and see what happens to that C3 where there were no dollar signs. When we go to the third row, the C2 was updated to C3, the C3 is updated to C4, and so on, but the 42 remains constant because we preceded the 42 with the dollar sign. So the cell address gets updated for the C2 part, but not for the C42 part. And so in each row of this data set, I have the price of the house minus the average price in my data set. I'm going to do the same thing for square footage. So I'm going to grab B2, I'm going to subtract out B42, but I want to hold the 42 constant with a dollar sign. So I'll put in a dollar there. And I'm going to now update that. It will update in a second. There we go. Okay. So now I have PI minus P bar, that is price minus average price. I have square footage minus average square footage. And according to my OLS formula, I have to multiply those two and then sum them up, and that goes in the numerator of the slope coefficient. So I have to have that times that. And there's no particular interpretation at this point to that number. We'll talk a little bit more about it in class, give you a visual representation or feeling for it. But we'll just copy it down the spreadsheet for now. Make this a little bit bigger so you can see it. And we're going to take the s minus s bar and square it. So that little caret and 2 means I'm going to raise this to the 2 power. And I will copy that down the worksheet as well. Those are big numbers because they're squared, so I can expand that a little bit. Don't really need that many decimal places, I guess. All right, so what am I going to do with this? I should now be able to sum, so I'm going to put in the formula sum. The SI minus S bar, PI minus P bar. And I'm going to sum the SI minus S bar squareds. And I should be able to form the ratio of the SI minus S bar to SI minus times PI minus P bar over the SI minus S bar squareds. So this should give me the exact slope coefficient for my regression. So what is that again? It's the sum of the PI minus P bar times SI minus S bars. Notice that we did the multiplication first, then we sum them. Otherwise you'd get a 0. Try that and you'll see. And we're dividing by the SI minus S bar squareds. Okay. Here's the so-called slope coefficient. That's our estimated B. According to the previous tutorial, if we take the YI bar, or in this case the PI bar, that's the price, and we subtract off B hat times S bar, we should get our estimated A. Okay, now we're going to see if that actually works. So if I were to simply create the scatter plot here, and insert, actually let me insert a chart. Okay. And here I have square feet on the x-axis, price on the y-axis. If I were to put a trend line in there, display the equation on the chart, and display our square, we'll get used to that as well. What do we see? We see that the slope is in fact 94.04, that's this number here, minus 13,084, that's this number here. So we've just calculated the OLS slope and intercept by hand. The formula we used, again, came from the grand minimization problem, where we were minimizing the sum of the squared residuals by choosing the correct A hat and B hat values.